Complete bipartite graph Km comma n has vertex covering number x and edge covering number y. X and y are respectively. Here 4 options are given and we have to select the correct option. Let us, in order to solve this problem, let us take one example. Let us take complete bipartite graph with 3, 4 edges. So one side there will be 3 edges and the other side there will be 4 edges. As it is complete bipartite graph, each vertex of one side is adjacent to every other vertex of the other side. That means here this vertex is adjacent to each vertex of the other side, and this vertex is also adjacent to all other vertex of the other side. So this is a graph. This is K3, 4 complete bipartite graph with 3 and 4 edges, vertices. For this graph, it is given that x is vertex covering number. X is vertex covering number and y is edge covering number. Vertex covering number is nothing but size of the minimum vertex cover. Vertex cover is nothing but set of all vertices such that all the edges of the graph should be incident on at least one vertex of the vertex cover. So for this graph we can say vertex number is nothing but minimum of m comma n. Why? Because vertex covering number is nothing but minimum number of vertices such that all the given edges, all the edges of the graph are incident to at least one of the vertex of that set. So let us take, if we take these three vertices, here all the edges of the graph are incident to these vertices. That means there is no edge which is not incident on these 3 vertices. So this, we can say this is the minimum vertex cover. So size of this minimum vertex cover is 3. So we can say vertex covering number is nothing but 3. So which is nothing but minimum of m comma n. So now let us find edge covering number. Edge covering number is nothing but size of the minimum edge cover. Whereas edge cover is nothing but set of all edges such that all the vertices of the graph are incident on at least one of the edges in that set. So here if we see the graph, we need if you see this graph, we need at least 4 edges in order to cover all the vertices. Why? Because if we take any 3 edges, let us take this edge, this edge, and this edge, we'll be missing at least one vertex. That means one vertex, there is at least one vertex which is not incident on any of the edges. So we should take at least minimum of 4 edges in order to cover all the vertices. So here edge covering number is nothing but 4. So x is given as vertex covering number, which is 3, and y is given as edge covering number, which is 4. So we can say for k m comma n, vertex covering number x is minimum of m comma n, and edge covering number y is nothing but maximum of m comma n. So here correct option is option D. Has 7 seats, 4 placed on one side facing towards window and 3 placed on the opposite side. In how many ways can 7 people be seated at the table if 3 people x, y and z have to be seated on the side facing towards window? Here it is given that there are 7 seats, out of which 4 are facing towards window and the remaining 3 are opposite side of facing towards opposite side of window. Here we have to find the number of ways in which 7 people can be seated if 3 particular people x, y and z have to be seated on the on the side facing towards a window. So let us there are 4 seats facing towards window, and let us put these 3 people x, y and z in these 4 seats. So this can be done in, this is nothing but arranging 3 dissimilar things in 4 places. This can be done in 4p3 ways, and here we have arranged 3 people and total there are 7 people, remaining are 4 people, and the remaining seats are among 7 seats we have already filled 3 seats with 3 people, that is x, y and z. So remaining are 4 seats, and 4 people can be seated in 4 places in 4p4 ways. So here the total number of arrangements is nothing but 4p3 into 4p4. So this is nothing but 4 into 3 into 2 into 4p4 is nothing but 4p4 is nothing but 4 factorial. Uh, 24 into 4 factorial is again 24. So 24 into 24, 576. So here the total number of arrangements is 576. So which is option A.